In previous session, we have discussed about what is pharmacokinetics. Pharmacokinetics means, I just quickly summarize this. It is the movement of the drug inside the body. When the drug is going to pass through the body, it is going to be absorbed, distributed, metabolized, and then ultimately the excreted. That's why it is also known as a ADME study. Then we have seen what is absorption. Absorption means that the movement of the drug from the site of the administration into the systemic circulation. Now, today we are going to discuss about the factors affecting the absorption. Which are the different factors that are going to affect the absorption? Okay. Now, there are n number of the factors. That are certain factors related to the drug, certain factors which are related to the physiology of the individual, and there are many factors that are related to the pathological states. Okay. The pathology of the individual, it can also affect the absorption of the drug. Now again, in the drug there are various factors such as particle size of the drug, then whether the drug is in the liquid state or the drug it is in a solid state, as well as whenever you are taking any tablets, that there are various inert substance like the lactose, sucrose, everything. So all these factors, they can also affect the absorption of the drugs. That is a totally different branch that is known as a biopharmaceutics. Then, as I have told you, the drug particle size, disintegration time, dissolution time. So there are n number of the factors related to the drug that are going to affect the absorption. Okay, but today we are not going to discuss about the factors related to the drug, but we will start discussing about the physiological factors. Okay, and in this we are going to discuss about the two factors. One is the surface area, and second is the, yes, that is related to the, now this factor is related to both, because ultimately the ionization status of the drug, it depends on both the parameters related to the drug also and the drug which is present in the medium also. So ionization status of the drug. Okay, so first we starts with the second one, ionization status of the drug. One should be very clear. Now there are two possibilities. Either the drug is strongly acidic or alkaline, and either the drug is weakly acidic and alkaline. Either the drug is strongly or weakly. Now one should be very clear that strongly acidic drugs, they are not going to be, or strongly acidic or strongly alkaline, they are not going to be absorbed. Okay, and the classical example is heparin. Okay, they are not going to be absorbed. Okay, while the weakly acidic drugs, they are, or the weakly alkaline drugs, they are going to be absorbed, whether the weakly acidic drug or weakly alkaline drug. Okay, now proceeding this further, one should be very clear that it is only the unionized part of the drug that is going to be absorbed. Okay, only the unionized part is going to be absorbed. Now I am giving you the one example, that aspirin. Aspirin is a weakly acidic drug. Aspirin is a weakly acidic drug. And if you just think that In which environment this drug remains unionized? Obviously, the acidic drug, if it remains in the acidic environment, it remains unionized. And where is the acidic environment? The acidic environment is there in the stomach. And that's why aspirin is better absorbed from stomach. So one can also say that if the drug is weakly acidic, if the drug is weakly acidic, it is better absorbed from stomach. Okay, this should be clear. If the drug is weakly acidic, it is better absorbed from stomach. Now, the next portion is if the drug is weakly alkaline. If the drug is weakly alkaline, say for example the morphine or pethidine, this type of agents. Now if this drug enters into the stomach, now the pH of the stomach is acidic. So what will happen? These acidic drug, these acidic environment, in this acidic environment, the morphine will be ionized. So morphine is not going to be absorbed from the stomach. But in case of when this drug enters into the duodenum or small intestine, duodenum and especially the small intestine, there is a slightly alkaline pH. Slightly alkaline pH. So, if the alkaline drugs enters into the duodenum and the small intestine, because of its alkaline pH, these drugs will remain unionized. So we can say that weakly alkaline drugs, they are better absorbed, or the weakly basic drugs, they are better absorbed from duodenum or small intestine. Okay, so one point is clear quickly. Weakly acidic drugs, they are better absorbed from stomach, and weakly alkaline drugs, they are better absorbed from small intestine. I just quickly note down this sentence. Okay, weakly acidic drugs better absorbed from stomach, and weakly alkaline drugs, they are better absorbed from small intestine. If we are following the rule of the ionization. Okay, this point is correct. Now, I have told you there is another factor, because ultimately the absorption of the drug, it depends on the many factors. I have told you there are n number of the drug related factor, pathological factor, physiological factors, and it is a sum total of the effect of all the factors that will decide the absorption of the drug. So there is another factor that I have told you, that the surface area of the drug, I have told you. So we have covered this ionization status. Now the next is the surface area. Okay, it is very obvious that larger the surface area, more will be the absorption. Now here you can see that the areas of the absorption, here you can see this is the stomach and this is small intestine. Now if you just without any knowledge, if you just broadly look at the figure, you will say that, sir, The surface area of the stomach is very large as compared to the small intestinal surface area. But it is absolutely wrong. You all know that the surface area of the stomach, अगर आप इसको enlarge करने जाओगे तो ये एरिया जो है वो बहुत बड़ा हो जाएगा. And further to this, if you just look at the small intestinal structure, there is a villi-like structure. So the area of the absorption, it is significantly more. So there is no comparison. There is no comparison of the surface area of the absorption between the stomach and the small intestine. There are thousand-fold more area for the absorption of small intestine as compared to the stomach. And that's why this is a more predominant factor. Surface area is the more predominant factor in deciding which the drug is absorbed from stomach or small intestine. And that's why whether it is acidic drug, whether it is an acidic drug or basic drugs, they are going to be absorbed from small intestine. So this theory proves wrong. Weakly acidic drugs better absorb from stomach, fine. Weakly alkaline drug better absorb from small intestine, fine. If you just look at the ionization status, that is fine. But उससे भी इम्पोर्टेंट जो कोई पॉइंट है तो वो पॉइंट है सरफेस एरिया. एंड दैट्स व्हाई दिस विल बी रॉन्ग वेदर it is acidic drug or it is an alkaline drug. Major amount of the drug is going to be absorbed from small intestine. Okay, I hope it should be clear. There are various other factors that we will discuss in subsequent sessions. Thank you.